Okay, so when most of us think about space exploration, our minds jump straight to those classic images, right? NASA, Apollo. Maybe that grainy black and white shot of Neil Armstrong on the moon.
Yeah, the iconic stuff.
Exactly. But what if I told you that actually the most exciting stuff happening in space right now, the really fast-moving innovation, it's not being driven by governments so much anymore. It's
Aw,
being powered by billionaires, by private companies, and some really audacious visions. Welcome to the deep dive.
great to be here.
Today, we're doing a deep dive into something genuinely out of this world, what people are starting to call Space Race 2.0.
Yeah, and that's a really key distinction to make right off the bat. The original space race, back in the Cold War.
Right, U.S. versus USSR.
Exactly. Sputnik in 57, Gagarin 61, Armstrong 69. That was all about ideology,
Mm-hmm.
national pride, military power, capitalism versus communism, that sort of thing.
Space Race 2.0. Fundamentally different beast. This new era, it's really about innovation moving at lightning speed. It's about bringing costs way, way down. And it's about collaboration, too.
Collaboration. Interesting.
Yeah, you've got these private companies working alongside, and okay, sometimes competing directly with the big national agencies like NASA, the European Space Agency, Roscosmos.
Gotcha. And we've dug into your source material here to try and cut through some of the noise. Our mission today really is to show you not just who these new players are,
Uh-huh.
but why they're completely changing the game, how it actually impacts your world down here on Earth, and, well, some of the pretty mind-bending ethical questions that come with it.
There are definitely a few of those.
Okay, let's unpack this. So maybe let's set the scene first.
Hmm.
This new frontier. When we talk about these private players in space, who are the big names we really need to know?
Well, the ones grabbing all the headlines, no doubt about it, are SpaceX. That's Elon Musk's company.
Blue Origin, which is Jeff Bezos' venture, and Virgin Galactic, Richard Branson's one.
The billionaire trifecta, basically.
Pretty much. But,
Yeah.
it's actually a much wider scene now. You've got companies like Rocket Lab. They specialize in launching smaller satellites.
Okay.
Relativity Space is doing some amazing stuff, 3D printing almost entire rockets.
Wow, really?
Yeah. And Axiom Space, they're aiming to build the first commercial space station. So it's a huge shift, a seismic shift, really, from just a few decades back when only governments had the money, the resources, the regulatory power to do anything beyond Earth.
Right. And it makes you wonder why now? I mean, this isn't just a few tech guys picking up a super expensive hobby, is it? What actually kicked off this explosion of private space stuff?
No, not just a hobby, definitely not. There are a few core things driving it. First, governments themselves, like NASA, they're actively looking for cheaper, more efficient ways to get to orbit and beyond.
Okay, that makes sense. Outsourcing.
Exactly. They've realized the private sector can often move faster, be more nimble, and frankly, cheaper. So they're contracting out more and more.
Right.
Second, these entrepreneurs, they don't just have the money, they have the long-term vision.
Yeah.
They're willing to sink capital into these incredibly ambitious, almost sci-fi goals that might not pay off for decades.
Patience and deep pockets.
You need both.
Yeah.
And third, just the technology itself has matured. Materials science, AI, robotics, all these advancements mean a well-funded startup can now actually achieve things that only huge government agencies could have dreamed of 30 years ago.
Huh.
And it creates this really interesting dynamic mix where, yeah, sometimes companies compete like crazy SpaceX and Blue Origin fighting over NASA contracts is a prime example.
Sure.
But often they collaborate too. NASA relies heavily on SpaceX's rockets now
Right.
to get astronauts to the ISS, for instance.
That makes total sense. And the knock-on effect is kind of amazing. It's not just making space cheaper, is it? It feels like it's speeding up innovation like crazy. Sort of like, I don't know, the smartphone revolution compared to old landlines.
That's a great analogy, actually. Yeah.
And it's also like democratizing access, isn't it? I mean, you read about universities, startups, even high schools being able to afford to send little satellites, CubeSats, into orbit now.
Absolutely. It opens up whole new areas for research, for commercial ideas. But let's maybe zoom in on those big three you mentioned, SpaceX, Blue Origin, Virgin Galactic. They're all space companies, but their actual missions seem, well, pretty different.
Yeah, very different.
Radically different, really. SpaceX, with Musk, has this incredibly ambitious, almost singular focus, making humanity multiplanetary.
Mars.
Mars is the big goal.
Yeah.
Their whole thing's reusable rockets. That's been the game changer, and just incredibly fast development. They're already essential for getting cargo and crew up to the International Space Station.
Okay, so that's SpaceX. What about Blue Origin, Bezos' company?
Blue Origin is playing a bit more of a foundational game, you could say. Their focus is more on building the core infrastructure needed so that eventually millions of people can live and work in space.
Millions. Wow.
Yeah, that's the vision. They emphasize long-term sustainability, developing large space habitats. Their whole approach is more methodical. Let's build the roads and the power plants, basically, for a future space economy.
Right. Build it so they will come.
Kinda, yeah. Laying the groundwork for a real, self-sustaining presence off Earth.
Okay. And then you've got Virgin Galactic. They seem like they're in a totally different category altogether.
They really are. Virgin Galactic, Branson's company, is laser-focused on opening up suborbital space tourism.
Yeah.
For people who can afford it.
The civilian market.
Exactly. They're offering these short trips, basically right to the edge of space. Think of it less as exploration and more like, well, like a very high-end entertainment or experience company, a luxury thrill ride.
So you get a few minutes of weightlessness, see the curve of the Earth.
It's an amazing view, yeah.
Yeah.
But you don't actually go into orbit. It's an exclusive, very high-altitude adventure.
Okay, so just to sort of boil it down, SpaceX is the big visionary pushing for Mars. Blue Origin is the architect building the foundations for future space cities, maybe. And Virgin Galactic is like the luxury space travel agent for the super rich.
That's a pretty good summary, yeah.
Speaking of which, costs. What has actually allowed these huge drops in cost, especially for rockets? Because historically, launching anything, even something small, into space was just astronomically expensive.
Oh, unbelievably so. You're absolutely right. I mean, historically, a single launch could run hundreds of millions of dollars. Easily.
Why so much?
Well, mainly because rockets were designed to be thrown away. They were single use. Imagine throwing away an entire airliner after just one flight.
Yeah, that would be insane.
Exactly. Materials were often custom made, not mass produced.
Yeah.
And governments who footed the bill maybe had less intense pressure for radical cost cutting compared to a commercial venture. SpaceX, especially with their Falcon 9 rocket, just completely flipped that script by mastering reusability. That iconic landing of the first stage booster.
Yeah, you see the videos. It's amazing.
It's not just cool to watch. It means the most expensive part of the whole rocket can be flown again and again. They refurbish it, fly it again. That single innovation has slashed launch costs from, maybe $400 million plus down to under $70 million per launch.
Wow, that's a game changer.
It really is. It makes space access so much more attainable.
Yeah, it really makes you think. It's not just about exploring space anymore, is it? It sounds like it's about building an actual economy in space. And that cost reduction is the key that's unlocking all these new commercial opportunities we're seeing.
Precisely. It's like a commercial gold rush happening right now.
Yeah.
Satellite deployment is booming. I mean, think about GPS, global internet, weather forecasting, all rely on satellites.
Right.
Companies are lining up to put constellations of satellites into orbit. SpaceX with Starlink is a huge example. Rocket Lab offers these affordable rideshare launches, kind of like an Uber pool for satellites.
Ah, okay.
Then you've got space tourism, like we mentioned, with Virgin Galactic and Blue Origin selling those short suborbital flights. And looking further out, companies are seriously betting on things like asteroid mining.
Asteroid mining, seriously?
Oh, yeah. For rare metals like platinum or even water ice, which you could potentially process into rocket fuel in space. There are plans for lunar settlements, Mars settlements. The gold is definitely seen as being in orbit and beyond.
But it's not just the private companies going it alone, right? Governments are still involved, playing a big role through these partnerships.
Oh, absolutely. Vital role.
Yeah.
Yeah, through what people call public-private partnerships. Governments still provide a lot of the funding, especially for the really long-term, ambitious science goals.
Setting the direction.
Exactly. But they've recognized that private companies often have that edge in speed, innovation, cost-effectiveness. NASA's Commercial Crew Program is the perfect example.
Right after the shuttle retired.
Yeah, after the shuttle retired in 2011, NASA had no way to launch its own astronauts from U.S. soil. It was relying on Russia. So they partnered with SpaceX, and now the Crew Dragon spacecraft takes astronauts to the ISS routinely.
And cheaper than before.
At a fraction of what it would have cost for NASA to develop a similar system entirely in-house. This whole model, often called New Space, it signifies this massive shift away from purely government-run programs towards these more commercially led, innovation-driven projects.
Okay, so we've got the players, we understand kind of the drivers, the cost reduction, the technology, the partnerships, but let's dig a bit deeper. How exactly are these companies reshaping space exploration? Not just making it cheaper, but fundamentally changing it.
All right, good question. So take SpaceX again. They didn't just build a rocket. Back in 2012, they were the first private company ever to send a spacecraft, their Dragon capsule, to dock with the International Space Station.
Okay, proving it could be done.
Exactly, proving a private entity could handle that kind of complex mission. And then, as we said, the Falcon 9 was the first orbital-class rocket to successfully land itself upright after launch and be reused. That wasn't just saving money. It fundamentally broke the old use it once, throw it away rocket model.
A paradigm shift, really.
Absolutely. And now their Starship, that giant stainless steel rocket they're testing.
The one that keeps having dramatic tests.
Well, yeah, rapid iterative testing, they call it. But it's designed from the ground up to be fully reusable, carry maybe up to 100 people, and its explicit goal is deep space travel, Mars colonization.
100 people.
Their stated ambition, Musk's ambition, is to make space travel eventually as common as air travel.
Yeah.
Launch is happening almost daily.
That's just hard to wrap your head around. Okay, what about Blue Origin's unique impact? You said they were playing the long game.
Yeah, they're really focused on that foundational infrastructure piece.
Mm-hmm.
The argument is, before we seriously talk about colonizing planets, we need reliable, reusable, heavy-lift rockets. We need permanent stations in orbit or near the moon. We need the ability to manufacture things in space.
In space manufacturing.
Yeah, using resources found there. Their New Shepard rocket is already taking tourists on those 11-minute suborbital flights, just past the Kármán line, the official edge of space.
Okay.
And they're developing New Glenn, which is a much, much larger orbital rocket designed for heavy payloads. Bezos' vision is really about moving heavy industry off Earth eventually to reduce pollution here. Millions living and working in space. Their motto is Gradatum Ferociter.
Which means...
Step by step, ferociously. It perfectly captures that methodical but determined foundational approach. Build the infrastructure step by step.
Okay. And Virgin Galactic, as you said, they've basically just created a whole new market segment, right?
Pretty much, yeah. They've turned reaching the edge of space into this exclusive luxury experience. Their spaceplane, VSS Unity, gets carried up by a mothership, detaches, fires its rocket.
Right, air-launched.
Exactly. Takes passengers up to around 100 kilometers, a few minutes of microgravity, incredible views. It's totally experience first, making space this bespoke bucket list adventure for those who can afford the ticket, rather than focusing on, say, science or resource extraction.
Okay, so this is where it starts to get, well, complicated. All this amazing innovation, all these private missions launching, it inherently raises some really big, important ethical questions, doesn't it?
Well, massively, yeah.
It's suddenly not just about engineers and astronauts anymore. It's about who owns space, who's responsible for the mess, who actually gets to benefit.
That's absolutely critical. Let's start with the most basic one. The privatization of space itself. The cornerstone is the 1967 Outer Space Treaty.
Okay, what does that say?
It famously states that space is the province of all mankind. No nation can claim sovereignty over the moon or Mars or any other celestial body. It basically treats space like international waters or Antarctica.
Right, belongs to everyone, owned by no one.
Exactly. But here's the catch. The treaty talks about nations. It doesn't really address private companies in the same way.
Ah, a loophole.
Well, a huge gray area. What happens when a private company, say, sets up a permanent base on the moon and starts mining water ice? Can they claim ownership of that land? Can they sell the resources they extract? Can they charge other people for access? There's a real risk of a kind of space land grab scenario where wealthy corporations could potentially dominate. Or you could argue the other way, that private investment is absolutely necessary if humanity is ever going to expand beyond Earth in a meaningful way.
So is space a common good, like a park, or is it open territory for a free market?
That's the fundamental tension right there. Should it be managed collectively or opened up? Big question.
Okay, and then there's the junk problem. More launches, more satellites. That means a lot more debris floating around up there, right?
It absolutely does.
Yeah.
It's a huge and growing problem. Every launch leaves something behind: old satellite bodies, spent rocket stages, fragments from collisions, even tiny things like paint flecks.
That they're moving incredibly fast.
It's astonishingly fast. Around 17,500 miles per hour, or 28,000 kilometers per hour, in low Earth orbit.
Yeah.
Even a tiny paint chip hitting a working satellite or the space station at that speed can cause catastrophic damage.
Right.
There are already thousands of defunct satellites just tumbling uncontrollably. And these new mega constellations like Starlink plan to launch tens of thousands more satellites.
Tens of thousands. Wow.
Now, the big fear is a collision triggering a chain reaction. One collision creates debris, which causes more collisions, creating more debris. It's called the Kessler syndrome.
And that could?
That could potentially render certain orbits, especially low Earth orbit, completely unusable for generations. It's just too dangerous to navigate.
So the ethical question is,
Who cleans it up? Who's responsible? Should the companies launching all this stuff be held financially liable for the pollution they're creating or for future cleanup efforts? How do you even enforce that?
complex. Okay. And one more big one, maybe closer to home, inequality. Right now, space tourism, it's purely for the ultra-rich, isn't it? Does this create a new kind of class divide, like an orbital aristocracy?
It's a very significant concern, and there's a really robust debate around it. Many people argue that, spending hundreds of thousands of dollars on a few minutes of weightlessness feels, well, out of touch when millions here on Earth lack basic things like food, clean water, healthcare.
Yeah, the optics aren't great sometimes.
The optics of launching rockets for leisure while the planet faces climate change and poverty, it's difficult for many to reconcile. And looking ahead, if companies do start mining asteroids or the moon for valuable resources, who benefits from that wealth?
Right. Does it get shared somehow, or does it just make the already rich even richer?
Exactly. Would concentrate wealth even further among a tiny elite? Critics often ask that question. Why spend billions going to Mars when we can't even fix the problems here on Earth?
But what's the counter argument?
The counter is often that the very act of pushing the boundaries, solving the immense technical challenges of space exploration and resource utilization, that process itself can lead to technological breakthroughs and potentially new resources that do benefit everyone back on Earth eventually. Think GPS, satellite communication, medical advancement.
Spin-off technologies.
Precisely. So it's this constant tension between, grand exploration and immediate terrestrial needs and social responsibilities.
Yeah.
And there are no easy answers at all. But the choices we make today about space ethics, about ownership, debris, equity, they're going to profoundly shape who gets to go to space and how it's used or protected for generations.
Okay, so let's try and gaze into the crystal ball a bit. What does all this actually mean for humanity's presence in space over the next, say, few decades? Because it really feels like we're talking about more than just a few isolated missions now.
Oh, we absolutely are. In the near term, let's say the next 10 years, maybe 2025 to 2035, we're looking at permanent moon bases becoming a reality.
Really? Permanent bases?
That's the goal. NASA's Artemis program is explicitly aimed at returning humans to the moon to stay. They're partnering with SpaceX, who are building a version of Starship specifically to land astronauts on the lunar surface.
Wow.
The plan includes lunar habitats, maybe using local resources, and a small space station orbiting the moon called the Lunar Gateway, sort of a staging post, all designed explicitly as preparation for eventual Mars missions.
So the moon is the stepping stone.
Exactly. We'll also definitely see space tourism become more common, probably evolving from these sort of one-off stunts into a more established, albeit still very luxury market, likely with multiple companies offering flights.
Okay. And those huge satellite constellations, like Starlink.
They're only going to get bigger.
Yeah.
Companies are launching thousands, aiming for tens of thousands of satellites to provide global high-speed internet.
The potential upside is huge, right? Connecting remote areas.
Immense potential, yeah.
Yeah.
Bridging the digital divide, helping in disaster zones. But, as we mentioned, it also brings major concerns about light pollution, interfering with astronomy, and just the sheer congestion and collision risk in orbit.
Right.
We'll also likely see the first private space stations. The ISS is aging.
It can't last forever.
Exactly. Companies like Axiom Space are already launching modules to attach to the ISS, planning to detach them later to form their own commercial station. Others, like the Orbital Reef project, backed by Blue Origin, are planning free-flying commercial stations. These could host private researchers, zero-G manufacturing, maybe even space hotel guests.
A commercial successor to the ISS. Okay. And then looking further out, mid to long term, say 2040 and beyond. This is where it gets really ambitious, isn't it?
This is where it gets really wild, yeah. This is the time frame when we anticipate seeing the first actual crewed missions landing on Mars.
Humans on Mars by the 2040s.
That's the goal many are working towards. SpaceX's Starship is being designed precisely for that purpose. Now, the challenges are enormous radiation exposure over the long journey, the psychological effects, how to build sustainable habitats.
Huge hurdles.
Massive hurdles. But the serious planning and development are underway. A human landing sometime in the 2040s is definitely within the realm of possibility being discussed.
Okay. What else? Asteroid mining.
Asteroid mining could become viable, yeah, especially for things like platinum group metals, which are rare on Earth but more abundant on some asteroids. Or maybe even more importantly, mining water ice from asteroids or the moon.
Water ice. Why is that so valuable?
Because you can split water into hydrogen and oxygen, which are the components of rocket fuel. So the idea is you could create space gas stations, basically.
Refuel ships in orbit or near the moon.
Exactly. Instead of hauling all your fuel up from Earth's deep gravity well, which is incredibly expensive, you could produce it in space using local resources. That could revolutionize deep space travel.
And that, I guess, leads to a whole new space-based economy.
Precisely. If you have reusable rockets, orbital stations, and in-space refueling and manufacturing, entirely new jobs and industries will start to emerge. Things we can barely imagine now.
Like what?
Well, space agriculture, how do you grow food off Earth? Off-world construction specialists? Microgravity pharmaceuticals? Some drugs might be manufacturable with higher purity and zero-G. Dedicated space lawyers. Orbital logistics firms.
Wow.
It'll demand whole new skill sets and training programs back here on Earth, too.
Yeah.
But, and it's a big but,
Yeah.
with all this potential activity comes the absolutely critical need for effective global space governance. Who gets to decide who can mine the moon? Who is liable if one company's satellite crashes into another's? Can countries or companies put weapon systems in orbit?
Yeah, the Wild West in space doesn't sound good.
Not sustainable. We're already seeing tension. On one hand, you have efforts towards global collaboration, like the U.S.-led Artemis Accords, which try to set norms for peaceful exploration. But on the other hand, you definitely have national competition heating up again, with China, Russia, India, the U.S., all pursuing their own ambitious, sometimes separate space programs. Expect major diplomatic wrangling over space law in the coming decades.
Okay, wow. So just to kind of wrap our journey here, we've gone from understanding this really fundamental shift from government-led space exploration to this vibrant, sometimes chaotic, new era driven by private companies. We've looked at the really distinct, ambitious missions of players like SpaceX, Blue Origin, Virgin Galactic, grasped why the costs are suddenly plummeting and opportunities are exploding.
Right, the reusability, the insane.
And we've confronted some of these big, really complex ethical questions about who owns space, the junk problem, the inequality issue.
Yeah, and what's truly fascinating, I think, is that these decisions being made right now, literally today, about things like moon bases, how we manage asteroid resources, how we govern space, these aren't just, sci-fi thought experiments for some distant future.
Real consequences now.
They were actively shaping an entirely new domain of human activity, maybe even human life itself. A domain where power, fairness, control. They're going to be constantly argued over, constantly negotiated. We are genuinely right at the beginning of this huge transformation.
So what does that all really mean for us, as we look out towards this potential multiplanetary future? Here's maybe something to think about. If we actually can make space travel as common as getting on an airplane, or if we can terraform Mars and make it habitable, what kind of new responsibilities come with that? What does it mean to become a truly spacefaring species? Is the ultimate goal here finding a plan B, a second home for humanity? Or are we maybe just exporting our problems, creating new, unforeseen challenges for future generations to deal with, but this time across the entire cosmos? Maybe the biggest deep dive we still need to take is into ourselves.
That's a profound thought to end on.
Stay curious.